The morning of June 19, 1944. 32,000 feet above the Philippine Sea, Lieutenant Tetsuzo Iwamoto scanned the crystalline blue horizon through the canopy of his Mitsubishi, a 6M0. The rising sun blazed to his east, a natural ally that had served Japanese naval aviators well for nearly 3 years. Below him, stretched across hundreds of miles of ocean, the largest carrier battle in history was about to begin. Iwamoto, one of Japan's highest-scoring aces with over 80 confirmed kills, felt the familiar weight of his flight suit and the lightness of his aircraft, a Zero that could outturn anything the Americans had ever put in the sky. He expected this day to unfold like so many others, American fighters rising to meet him, heavy and sluggish, perfect targets for the lightning-quick Zero. What he did not expect, what no amount of training or combat experience had prepared him for, was the fundamental change in how Americans had learned to kill. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The mythology of Japanese aerial supremacy had been built on a foundation of undeniable early victories. From December 7, 1941, through the spring of 1942, Japanese naval aviators had carved through Allied air forces with a precision that seemed almost supernatural. The Zero fighter, officially designated the Type 0 carrier fighter, had become a legend even among its enemies. Weighing just over 5,000 pounds empty, powered by a Sakai radial engine producing 1,100 horsepower, the Zero could climb faster and turn tighter than any Allied fighter in the Pacific theater. Its range was extraordinary, over 1,600 miles with external fuel tanks, allowing Japanese pilots to strike targets their enemies thought were safely beyond fighter escort range. When American pilots at Pearl Harbor and across the Philippines first encountered Zeros, they reported something that seemed impossible: an enemy fighter that was simultaneously long-ranged, highly maneuverable, and capable of sustained high-altitude performance. But the Zero's legendary agility came at a price that Japanese naval architects had consciously chosen to pay. To achieve such performance with limited engine power, Mitsubishi's designers had stripped away almost everything that didn't contribute directly to flight performance. The Zero had no armor plating to protect the pilot. Its fuel tanks were not self-sealing, meaning a single incendiary round could transform the aircraft into a flying torch. The wing structure, though aerodynamically brilliant, was built so lightly that high-speed maneuvers could cause structural failure. The two 20mm cannons and two 7.7mm machine guns provided reasonable firepower, but the entire weapons system was designed around the assumption of precision rather than overwhelming force. Japanese doctrine emphasized individual pilot skill, the samurai tradition of the lone warrior, the ace who could place his shots with surgical accuracy. In the hands of a superbly trained pilot, and Japanese naval aviators in 1942 received some of the most rigorous training in the world, the Zero was a scalpel that could carve through enemy formations with devastating effectiveness. The American response to early encounters with the Zero had been chaos, then analysis, then adaptation. By mid-1942, U.S. Navy intelligence had compiled detailed reports from surviving pilots, examined captured examples, and begun to understand both the Zero's capabilities and its vulnerabilities. The conclusions were sobering. American fighters like the F6F Hellcat could not outturn, outclimb, or outrun a Zero in a traditional dogfight. But American engineers and tacticians also recognized something the Japanese doctrine did not emphasize. Air combat was not just about maneuverability, it was about energy management, situational awareness, and the ability to dictate the terms of engagement. The solution came in two forms: new tactics and new technology. The tactical revolution began with men like Lieutenant Commander John S. Thach, who developed the Thach Weave, a defensive maneuver where pairs of fighters would cross back and forth, covering each other's tails, and denying Japanese pilots the clean deflection shots they needed. But defensive tactics could only achieve so much. What American forces needed was an aircraft that could turn the tables, that could use its strengths to exploit the Zero's weaknesses. That aircraft arrived in January 1943, when the Grumman F6F Hellcat entered combat operations. The Hellcat was everything the Zero was not. It weighed over 9,000 pounds empty, nearly twice the Zero's weight. Its Pratt & Whitney R2800 double Wasp engine produced 2,000 horsepower, almost double the Zero's output. This raw power translated into speed. The Hellcat could reach 380 miles per hour in level flight and could exceed 400 miles per hour in a dive, speeds at which a Zero's controls became mushy and dangerous. But speed was only part of the equation. The Hellcat carried armor plate behind the pilot's seat and head, protecting him from rear attacks. Its fuel tanks were self-sealing, able to absorb hits and automatically close punctures. The airframe was massively overbuilt by Japanese standards, capable of absorbing tremendous battle damage and still bringing its pilot home. It carried 6 50-caliber Browning machine guns, each capable of firing 800 rounds per minute, creating a cone of fire that could see through a Zero's lightweight structure like a chain saw through balsa wood. But hardware alone did not win battles. The true revolution came in how American pilots were trained to use their new weapon. By late 1943, U.S. Navy fighter doctrine had been completely rewritten. The old ideas of turning dogfights and individual combat prowess were replaced with energy tactics, mutual support, and the ruthless exploitation of the Hellcat's advantages. New pilots were drilled endlessly in boom and zoom attacks. Climb high, use the sun for concealment, identify targets, dive at maximum speed, fire a brief burst, and extend away before the enemy could respond. Never turn with a Zero, never slow down in a Zero's airspace, never fight the enemy's fight. Use altitude, use speed, use teamwork. Strike and escape. Return with altitude advantage and strike again. The tactical doctrine was supported by an industrial reality that Japanese planners had catastrophically underestimated. By 1944, American shipyards were completing one new aircraft carrier every month. American factories were producing over 9,000 fighter aircraft every month, including over 500 Hellcats. Pilot training programs were graduating thousands of new aviators, each with over 300 hours of flight time before entering combat. The American military machine was not just replacing losses, it was expanding geometrically, creating a force that could trade casualties at rates that would have been strategically disastrous for any other nation and still grow stronger. Japanese aviation, by contrast, was dying the death of irreplaceable attrition. The elite pilots who had trained for years before the war, who had perfected their skills in China and at the war's opening, were being killed in ones and twos, month after month. Each loss was catastrophic because Japan's training infrastructure could not replace such expertise. By mid-1944, the average Japanese naval pilot had less than 100 hours of flight time before entering combat. They flew the same Zero that their predecessors had flown, but they lacked the skill to exploit its advantages. They faced American pilots who had 3 times their training, who flew aircraft specifically designed to kill Zeros, and who fought with tactics that reduced air combat to a mechanical process of energy management and patience. Lieutenant Iwamoto understood these realities intellectually, even if the Japanese command preferred to speak of spirit over statistics. He had survived 3 years of combat because he was not bound by doctrine alone. He adapted, he learned, he respected his enemies even as he killed them. He knew the Americans had better aircraft now. He knew they were coming in greater numbers, but he also knew that skill still mattered, that a truly exceptional pilot in a Zero could still achieve kills against the heavier American fighters. What he did not fully grasp, what perhaps no Japanese pilot could fully grasp until they experienced it personally, was how completely American doctrine had changed. The Americans were no longer trying to dogfight, they were hunting. The radio crackled with urgent calls in Japanese. Radar operators on the Japanese carriers had detected the incoming American strike, over 200 aircraft approaching from the east. Iwamoto and his fellow pilots advanced their throttles and began climbing, positioning themselves between the enemy and their fleet. The tactical situation was classic. Japanese fighters would intercept the American bombers, shooting them down before they could reach the carriers. American fighters would try to protect their bombers. Individual combats would develop. The skilled would triumph. This was the pattern that had held for 3 years. But on this morning, 32,000 feet above the Philippine Sea, the pattern was about to break. The American aircraft appeared first as distant specks against the morning sky, then resolved into the familiar shapes of Helldivers and Avengers, the bombers that Japanese pilots had learned to fear and respect. But surrounding them, above them, and spread in a pattern that seemed almost casual, were the Hellcats. Dozens of them, perhaps over 100. They were not diving immediately to engage. They were not forming tight defensive circles around their bombers. They were simply climbing, maintaining position, and waiting. This should have been the moment when Iwamoto and his fellow Zero pilots pressed their attack, diving onto the bombers from above, scattering the formation, forcing the American fighters to react defensively. Japanese doctrine called for aggressive interception, for the offense that kept enemies off balance. Iwamoto began his dive, leading his section toward the bomber formation. Several other Zero pilots followed, their aircraft pristine and deadly in the morning light. What happened next occurred so quickly that later, in debriefings and scattered survivor accounts, Japanese pilots would struggle to reconstruct the sequence of events. The Hellcats did not turn to engage the diving Zeros. They did not break formation to protect the bombers in individual combat. Instead, sections of American fighters, always in pairs, always maintaining mutual support, simply pushed their noses down and accelerated. The massive Pratt & Whitney engines roared as the Hellcats transitioned from level flight into steep dives, their speed building rapidly. 320 miles per hour, 350, 380, 400. The physics were brutally simple. The Hellcats had been positioned several thousand feet above the Japanese fighters. When they dove, gravity and engine power combined to create speeds that the lighter Zero could match only by also diving, but doing so would take the Japanese pilots away from their mission of defending the fleet. The American tactic exploited this dilemma mercilessly. If the Zeros continued toward the bombers, the diving Hellcats would overtake them from behind and above, the worst possible attack, angle. If the Zeros turned to engage the Hellcats, they abandoned their defensive mission and entered a fight where speed and altitude determined survival. Iwamoto saw the first Hellcat pair accelerating toward him from his 11 o'clock high position above and to his left front. He had perhaps 3 seconds to decide. His instinct, honed by years of combat, was to turn into the attack, to use the Zero's superior maneuverability to force the Americans into a turning fight where his lighter aircraft would dominate. He broke hard left, pulling the control stick back and rolling into the turn. The Zero responded instantly, its low wing loading and powerful ailerons allowing it to change direction with a quickness that still astounded even experienced pilots. For just a moment, Iwamoto felt the old confidence. The Americans would overshoot, their heavier aircraft unable to follow his turn, and he would reverse and gain position on them. But the Hellcats did not try to follow his turn. They did not attempt to engage in the turning fight he had prepared for. The lead Hellcat fired a brief burst. Iwamoto saw the tracers arc past his canopy, missing by perhaps 20 feet, and then both American fighters extended straight ahead, their speed carrying them through and past his position before he could bring his guns to bear. In less than 4 seconds, they had entered his airspace, fired, and escaped, trading altitude for speed and using that speed to disengage before he could respond. They did not loop around for another pass. They climbed back toward the sun, rebuilding the altitude they had traded for speed, positioning themselves for another attack on another target. Around him, the sky had become a chaos of similar encounters. Zeros turned and turned, burning fuel and energy in tight circles, trying to force Americans into dogfights that never materialized. Hellcats dove from above, fired quick bursts, and extended away, climbing back to altitude advantage. The American fighters were not fighting individual duels. They were executing a systematic process of energy management. Each attack traded altitude for killing speed. Each successful or unsuccessful pass ended with a climb back to the sun, back to the position of advantage. The Hellcats never stayed low. They never followed zeros into the weaving, turning fights that Japanese pilots had trained their entire careers to win. The results were catastrophic. A zero in Iwamoto's peripheral vision suddenly erupted in flames, its unarmored fuel tank ignited by 50 caliber incendiary rounds. The pilot never had time to bail out. The aircraft tumbled, burning into the sea 30,000 feet below. Another zero, piloted by a young replacement pilot with perhaps 40 hours of flight time, attempted a climbing turn to pursue a departing Hellcat. The American pilot simply pushed his throttle forward and extended, his superior speed creating separation that the zero could never close. Meanwhile, the Hellcat's wingman dove from above, catching the zero in its climb when it was slow and vulnerable, and the concentrated fire from 6 50 caliber machine guns literally sawed the Japanese fighter's tail section off. The wreckage spiraled downward, pieces separating in the slipstream. Iwamoto recognized the tactical trap too late. The Americans had no intention of protecting their bombers through dogfighting. They were protecting them by systematically destroying the Japanese fighter force using altitude, speed, and patience. Every zero that turned to chase an escaping Hellcat burned energy and lost altitude. Every zero that tried to climb back to advantage found itself slow and vulnerable to the next boom and zoom attack. The American doctrine was not about individual skill or honor or the test of the samurai warrior. It was about physics, about energy states, about reducing air combat to a problem of geometry and relative velocity. The Americans had studied the mathematics of killing and had built both an aircraft and a tactical system to execute that mathematics with industrial efficiency. The bombers, meanwhile, continued their approach largely unmolested, with the Japanese fighters consumed by their desperate attempts to engage the Hellcats. American Helldivers and Avengers proceeded toward the Japanese carrier fleet, beginning their attack runs. The entire Japanese defensive plan had collapsed not because the defenders lacked courage or even skill, but because the tactical assumptions on which that plan was built had been rendered obsolete by an enemy who refused to fight the expected fight. After approximately 12 minutes of combat, though to the pilots involved, it seemed both longer and shorter, Iwamoto's fuel gauge showed he had burned nearly 40% of his fuel load. He had fired perhaps 30 rounds, had not scored a single hit, and had seen at least 4 zeros from his air group shot down or damaged. The Americans, by his count, had lost perhaps 1 or 2 aircraft to all causes. The exchange ratio was not just unfavorable, it was catastrophic, and still the Hellcats circled above, diving and climbing, mechanical in their precision. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Battle of the Philippine Sea, which American pilots would come to call the Great Marianas Turkey Shoot, continued for 2 more days. But the outcome was decided in these first hours of June 19th, when the fundamental shift in tactical doctrine became undeniable. Japanese forces launched over 370 aircraft in 4 separate waves that day. American forces shot down more than 300 of them. The U.S. Navy lost approximately 20 aircraft in air-to-air combat. The kill ratio was approximately 15-1 in favor of the Americans. But these numbers, devastating as they were, did not fully capture the nature of the defeat. The Americans had not simply won a battle, they had demonstrated that Japanese tactical doctrine was fundamentally broken. The samurai tradition of individual combat prowess, the emphasis on the turning dogfight, the acceptance of aircraft vulnerability in exchange for maneuverability. All of these had been rendered strategically irrelevant by an enemy who had studied the problem of air combat and solved it with a combination of superior technology, superior training infrastructure, and tactical doctrine that reduced killing to a systematic process. Lieutenant Iwamoto survived the battle. He would continue flying combat missions until the war's end, ultimately claiming over 200 victories and becoming one of Japan's highest-scoring aces. But even he, with all his skill and experience, recognized that something fundamental had changed on June 19, 1944. In his later accounts, he described the frustration of facing an enemy who would not fight on his terms, who treated air combat not as a test of warrior spirit, but as a problem of engineering and physics. The Americans, he noted, fought with their brains and their industry, not merely with their hearts. They had turned air combat into something mechanical and, in its own way, far more deadly than the individual duels of skill that Japanese doctrine celebrated. The tactical lessons of the Philippine Sea battle spread rapidly through the remaining Japanese naval air forces. But knowing what the Americans were doing and being able to counter it were two different problems. Japanese aircraft designers attempted to create fighters with better high-speed performance, resulting in aircraft like the J-2M Raiden and the N-1KJ Shiden, but these arrived too late and in too few numbers to matter. Japanese training programs attempted to teach new pilots the energy tactics necessary to survive against Hellcats, but this required flight time and fuel that Japan's collapsing economy could no longer provide. By late 1944, the average Japanese naval pilot had less than 50 hours of total flight time. They were being sent into combat in obsolete aircraft, using obsolete tactics against an enemy that had every advantage: better aircraft, better training, better tactics, and overwhelming numerical superiority. The industrial statistics told the story of inevitable defeat. In 1944, the United States produced over 96,000 military aircraft. Japan produced 28,000. American factories delivered over 6,000 Hellcats that year alone. Japanese factories struggled to build 2,000 Zeros, many of which were destroyed on the ground by American bombing raids before they ever reached combat units. American pilot training programs graduated over 75,000 new aviators in 1944. Japanese programs graduated perhaps 8,000, many of whom died in their first combat mission. The material disparity extended to every aspect of the air war. American carriers operated with a logistical tail that ensured continuous supplies of fuel, ammunition, spare parts, and replacement aircraft. Japanese carriers, when they still existed, often operated with partial fuel loads and limited ammunition due to submarine interdiction of supply routes. American pilots who were shot down in the Pacific often survived, picked up by rescue submarines or seaplanes that specifically searched for downed aviators. Japanese pilots who ditched in the ocean usually died within hours, as the Imperial Navy had no systematic rescue infrastructure. This meant that American air crews gained experience over multiple combat tours, while Japanese air crews, even the skilled ones who survived their first battles, were eventually lost through attrition with no means of rescue. The tactical revolution represented by the Hellcat and its doctrine was not just about one aircraft or one battle. It represented a fundamental shift in how industrialized nations would wage air warfare for the remainder of the 20th century. The lessons learned in the Pacific that air combat was about energy management, mutual support, and the ruthless exploitation of technological advantages would be codified in fighter doctrine by every major air force. The romantic notion of the dogfighting ace, the individual warrior testing his skill against another in single combat, would persist in mythology but would increasingly become strategically irrelevant. Modern air combat would be about systems, about networked situational awareness, about missiles fired from beyond visual range, about pilots who might never see their opponents except as radar returns and infrared signatures. For the Japanese naval aviators who survived the Philippine Sea battle, the months that followed were a descent into increasingly desperate circumstances. The Imperial Japanese Navy had lost 3 aircraft carriers in the battle, not to American aircraft, but to American submarines that stalked the Japanese fleet and sank the carriers Shokaku, Taiho, and Hio with torpedo attacks. More critically, Japan had lost the majority of its trained carrier pilots. The Imperial Navy would never again be able to mount a credible carrier aviation operation. The few skilled pilots who remained, men like Iwamoto, found themselves transferred to land-based units, flying from island airfields against increasingly overwhelming American raids. By October 1944, during the Battle of Leyte Gulf, Japanese naval aviation had been reduced to a force that bore almost no resemblance to the elite cadre that had struck Pearl Harbor less than 3 years earlier. The skilled pilots were mostly dead. The replacements had minimal training. The tactics had not evolved to counter American doctrine. In desperation, Japanese commanders began organizing Tokubetsu Kogeki-tai special attack, units better known to history as kamikaze. If Japanese pilots could no longer survive air combat against Hellcats and the newer F4U Corsairs, then they would instead load their aircraft with explosives and dive directly into American ships. The kamikaze attacks represented not just a tactical shift, but a psychological admission of defeat. Japanese aviation could no longer contest American control of the sky through conventional means. The Hellcat continued to dominate Pacific skies through the war's end, in August 1945. The final tally was staggering. Hellcat pilots claimed over 5,156 aerial victories against approximately 270 Hellcats lost in air-to-air combat, a kill ratio of 19-1. No other fighter aircraft in history has achieved such a favorable combat record over such an extended period and against such widespread opposition. The Hellcat's success was not due to any single revolutionary technology. It was not the fastest fighter, nor the most heavily armed, nor the longest ranged. Its success came from the combination of good design, excellent pilot training, superior tactical doctrine, and the industrial capacity to deploy these advantages on a scale that no enemy could match. Individual American Hellcat pilots achieved remarkable success using the tactics developed and refined through bitter experience. Commander David McCampbell, the Navy's leading ace, scored 34 confirmed kills, most while flying Hellcats. On October 24, 1944, during the Battle of Leyte Gulf, McCampbell engaged a formation of over 60 Japanese aircraft with just his wingman as support. Using textbook energy tactics, diving from altitude, making brief firing passes, extending away, and climbing back to advantage, McCampbell shot down 9 Japanese aircraft in a single mission, and his wingman accounted for 6 more. The 15-2 exchange ratio, in this single engagement, mirrored the overall statistics of Hellcat combat operations. McCampbell survived the war, and later emphasized in interviews that his success came not from individual heroism, but from systematic application of the tactical doctrine he had been taught. Maintain altitude advantage, attack from the sun, make one pass and extend, climb back to advantage, repeat. The Zero, meanwhile, continued to be produced until the war's final days, but it was operated increasingly by pilots who lacked the skill to exploit its advantages, and who faced overwhelming tactical and numerical odds. Late-war Japanese attempts to improve the Zero resulted in variants like the A6M5 and A6M8, which incorporated slightly better armor, sealed fuel tanks, and more powerful engines. But these improvements came too late and in too few numbers. By 1945, most operational Zeros were being used for kamikaze attacks, their maneuverability advantages irrelevant when the pilot intended to crash the aircraft into a target anyway. The psychological impact on surviving Japanese pilots was profound. Post-war interviews with men like Saburo Sakai, another high-scoring Japanese ace who survived the war, reveal a deep sense of betrayal not by their commanders or their nation, but by the circumstances of industrial warfare itself. These men had trained for years to become superlative fighter pilots, mastering a craft that required exceptional skill, discipline, and courage. They had believed that individual excellence would prove decisive in combat. Instead, they had discovered that individual skill meant very little when facing enemies who had superior aircraft, superior numbers, superior tactics, and an industrial system that could replace losses faster than they could inflict them. Sakai himself was wounded in a combat engagement in 1942, losing vision in one eye, but continuing to fly combat missions. He survived the war, but spoke afterwards of the bitterness of watching younger, less skilled pilots sent to die in obsolete aircraft against an enemy that treated air combat as an industrial process rather than a test of warrior spirit. The technical lessons of the Pacific Air War influenced fighter design for decades. Post-war American fighters like the F-80 Shooting Star, the F-86 Sabre, and eventually the IV Phantom emphasized speed, altitude, performance, and heavy armament over pure maneuverability. Soviet fighters followed similar design philosophies, as did British and French designs. The idea that a fighter should be light and maneuverable above all other considerations was largely abandoned. The new generation of fighters was designed around the assumption that combat would involve high-speed passes, limited turning engagements, and increasingly, beyond visual range missile combat. The dogfighting ace, the pilot who won through superior turning ability and close-range gunnery, became a historical artifact rather than a doctrinal goal. The Hellcat itself had a remarkably short service life, despite its combat success. By 1949, just 4 years after the war's end, the U.S. Navy had retired nearly all Hellcats from frontline service, replacing them with jet fighters. Some Hellcats were transferred to reserve units, some to foreign air forces, and many were simply scrapped. The aircraft that had dominated the Pacific had become obsolete almost overnight as jet propulsion revolutionized military aviation. Today, fewer than a dozen airworthy Hellcats remain, most in the hands of private collectors or museums. They are flown at air shows occasionally, where they demonstrate the same solid, stable handling characteristics that made them such effective weapons platforms. But they are slow by modern standards. An F-16 can exceed the Hellcat's top speed while still on its takeoff roll, and they seem almost quaint compared to modern fighters that can exceed the speed of sound and carry guided sounded missiles, with ranges measured in dozens of miles. The broader lesson of the Hellcat's success extends beyond aviation history into the nature of modern warfare itself. The Pacific Air War demonstrated that in industrialized conflict, systematic advantages in training, logistics, and tactical doctrine can overcome individual excellence. The romantic notion of war as a test of individual courage and skill, the idea that the better warrior will triumph through force of will and superior technique, was revealed as increasingly irrelevant when faced with an enemy that approached warfare as an engineering problem to be solved through superior systems and overwhelming material resources. This realization had profound implications for Japanese military culture. The samurai tradition that had shaped Japanese military thought for centuries emphasized individual honor, personal courage, and the cultivation of martial skills through lifelong discipline. These values had served Japan well in earlier conflicts against enemies who shared similar technological levels and military traditions. But against the United States, which approached warfare through the lens of industrial efficiency and mass production, these traditional values proved strategically inadequate. The Americans did not care about individual duels or tests of skill. They cared about production numbers, logistics chains, training pipelines, and tactical systems that could be taught to average pilots and executed with mechanical precision. The cultural clash was not just between two nations, but between two fundamentally different philosophies of warfare. Lieutenant Tetsuzo Iwamoto, the pilot whose perspective began this story, survived the war and lived until 1995, long enough to see the world that had emerged from the conflict he had fought in. He witnessed Japan's transformation from militaristic empire to peaceful, prosperous democracy. He saw Japanese industrial prowess, once directed toward military production, create an economic miracle that made Japan one of the world's wealthiest nations. He watched as Japanese automotive and electronics companies used the same systematic approach to quality and efficiency that American forces had used in warfare and achieved global dominance in civilian markets. The irony was not lost on observers. Japan had lost the war using traditional martial values, but had won the peace using the industrial and systematic approaches that had defeated them. In his final interviews, Iwamoto spoke with remarkable clarity about the lessons of his combat experience. He acknowledged that he and his fellow pilots had been superbly trained for a kind of warfare that was already becoming obsolete as they fought it. They had perfected the art of the turning dogfight, just as the turning dogfight was being replaced by energy tactics and boom and zoom attacks. They had embraced the mythology of the warrior ace, just as air combat was becoming a matter of systematic doctrine, and industrial production. He did not express bitterness about this. He recognized it as the reality of technological change and the nature of total war between industrial powers. But he emphasized that the individual pilots on both sides had been brave, skilled, and dedicated. The outcome had been determined not by these individual qualities, but by the systems and resources each side could bring to bear. The morning of June 19, 1944, above the Philippine Sea, represented a pivot point not just in World War II, but in the nature of aerial warfare itself. It was the moment when it became undeniable that industrial capacity, systematic doctrine, and technological advantage had permanently overcome the traditional elements of individual skill and warrior culture in determining the outcome of air combat. The Japanese aces who flew that day were among the most skilled fighter pilots in the world, but skill alone could not overcome the mathematics of energy tactics, the reality of overwhelming numerical superiority, or the systematic doctrine that American pilots executed with mechanical precision. The Hellcats that dove from the sun at 400 miles per hour were not flown by supermen or legendary aces. They were flown by average pilots, most with less combat experience than their Japanese opponents, who had been taught a system and trusted that system to keep them alive and make them effective. The system worked. The mythology did not. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.